All right, so obviously this is how we use the unit circle. We talked about how to actually fill in yesterday. As a reminder, you will do that as part of your quiz, okay? And then today is why. Like, why do we even know what the unit circle is? And we're going to finish with a little bit of calculator use. So if you have your calculators, you need to get them out. So this is like obviously where the unit circle comes from. The unit circle is a circle with a radius of 1. So if I move out by a unit of 1 in all directions, it forms the lengths that make those coordinate points, okay? We use that to fill in our x and y's, and then we use our x and y's to determine sines and cosines. That's where the link all comes from. There are 6 trig functions, okay? It is sine, cosine, tangent, which we've heard about for a long time. And then there is cosecant, secant, and cotangent. We will almost always use the abbreviation. So sine is SIN, cosine is COS, tangent is TAN, cosecant is CSC, secant is SEC, and cotangent is COT. For any triangle, you can use SOHCAHTOA. We all know that word, right? SOHCAHTOA tells you that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, the tangent is opposite over adjacent, and then the reciprocal functions would be the flip of that. For a unit circle where your radius is 1, you can just use the coordinate points. So sine is y, because it would be y over 1. That would be your radius, but that 1 goes away. Cosine is the x. The tangent is the y over the x. The cosecant is the reciprocal of sine, or 1 over y. The secant is the reciprocal of cosine, or 1 over x. And the cotangent is the reciprocal of tangent, or x over y. We remember this from last year, yes? Okay. So if I'm given the coordinate point at the beginning and it asks you to find the 6 trig functions, I'm going to start in the same order. So sine, and the angle here is t. So sine of t, cosine of t, tangent of t, and then cosecant of t, secant of t, and cotangent of t. We said the sine is the y. So in this one, it'd be root 3 over 2 and 1/2. The cosine is the x. So this would be 1/2. Now, tangent is y over x. I'm going to teach you a trick, but for right now, we're going to say, what happens if I don't know the trick? Tangent's y over x. So I'm going to take the root 3 over 2, and I'm going to put it over 1/2. And then I would change flip this, and I just get root 3. So tangent is root 3. The cosecant is the reciprocal of root 3 over 2. So it'd be 2 over root 3, and we have to rationalize this. So I get 2 root 3 over 3. Secant is the reciprocal of cosine. So I flip the 1 over 2, I get 2. And tangent, or cotangent, is the reciprocal of tangent, which would be 1 over root 3. And I have to rationalize it. So if I don't remember the tangents, but I'm going to strongly encourage you to memorize the tangents. If you don't remember the tangents, then you would do that, okay? All right, now we're going to go a step further and say I don't already know the point, but I have the angle. So find the point x, y on the unit circle that corresponds to the real number t. If you pull in your unit circle, okay, if you go to 2 pi over 3, you'll see your coordinate point there is negative 1/2 and root 3 over 2. So that one just wants the point. Then it's going to ask you specifically sine, cosine, tangent of this angle. While we're here, let's talk about our tangents. So if you open up your unit circle, the one you drew out yesterday, your tangent, so at the top we did our pi over 6, right? We did over 6's, our root 3 over 2 and 1/2. All right, yesterday we did this. Every over 6 is root 3 over 2 and 1/2. Every over 4 is root 2 over 2, and every over 3 is 1/2 and root 3 over 2. So for a tangent, every over 6 is root 3 over 3. For over 4, the tangents are 1. And for over 3, the tangents are root 3. If you don't memorize them, then you can put y over x. But if you can memorize them, that's half the battle. So for me, I remember that 6 would be 3 plus 3. So I need 2 3's to get it. And 3 would just be 1, 3, so that's why it's just 1, 3. And then the over 4s are 45, 45, 90 triangles, which would make sense that the x and the y are the same. And if the x and the y are the same, my tangent's 1. On the right and the left, y over x would be 0 over 1. So my tangent is 0. And at the top and the bottom, it would be 1 over 0. So my tangent is undefined. And then notice these corners now, because everything is positive in the first quadrant, your sine, your cosine, your tangent, your secant, your cosecant, and your cotangent would all be positive in the first quadrant. So my tangent here would be positive root 3 over 3, 1, and root 3. In the second quadrant, because the x is negative, that would make my cosine negative. And if my cosine's negative, then my tangent's negative. So in that spot, my tangent would be negative. So this would be negative root 3 over 3. This would be negative 1, and this would be negative root 3. And in the bottom left, in the third quadrant, both your x and your y's are negative, which would make your sine, cosine, secant, and cosecant negative, but your tangent and cotangent positive. This would be a positive root 3 over 3, a positive 1, and a positive root 3. And in the fourth quadrant, your x is positive, your y is negative, so your cosine and your secant are positive, and everything else is negative. This would be a negative root 3 over 3, a negative 1, and a negative root 3. Now, when you go to write this out for a quiz or test, I would say maybe you don't need to write out every tangent, but just knowing the top part, knowing your over 6, your over 3, and your over 4s will help you, and then you just have to apply your sign. Do you remember the acronym? The PG version of it is all students take calculus. Though that letter represents the trig function of your original 3 that are positive. So in the first quadrant, they are all positive. In the second quadrant, sine is positive, everything else is negative. In the third quadrant, tangent is positive, everything else is negative. And in the fourth quadrant, cosine is positive, everything else is negative. All right, so now we're going to go to the actual trig functions one step further. Evaluate if possible the sine, cosine, and tangent of the real number. So we just said our coordinate point for 2 pi over 3 was negative 1/2 and root 3 over 2, which means our sine is the y, root 3 over 2. Our cosine is the x, negative 1/2. And the tangent, it's an over 3 in the second quadrant, so it's negative root 3. Questions on that one? Okay, the next one, so I'm going to bring this back in. The next one is a negative angle. So there are 2 ways to get to a negative angle. I'm going to teach you both and then you decide. One is the way it's defined, which is instead of going counterclockwise, we go clockwise. So we would go clockwise to the first pi over 3 here. If I do that, I'm going this direction, and this would be negative pi over 3. What I think is easier is method 2, which is find that where it's positive, pi over 3 is here, and then fold your unit circle like a hamburger, top to bottom. And where it overlaps is where it would be negative. So based on that, this is the coordinate point I'm using. My cosine, or let me go in the same order. My sine is negative root 3 over 2. My cosine is 1/2. And my tangent, fourth quadrant, so it's negative. And it's over 3, so it's root 3. Questions on that one? Okay, now C. What do you notice about 6 pi over 3? It's just 2 pi. So program yourself now. Check. Can I simplify it first? Yes. 2 pi is located where? Where's 2 pi on your circle? Thank you. All the way on the right-hand side, where 0 is, right? So my sine is the y, which is 0. My cosine is the x, which is 1. And my tangent, we said, would be y over x, or 0. Questions so far? All right, domain and range of sine basically says the domain of the sine and the cosine function is a set of all real numbers. So domain is your x coordinates. As you go around your unit circle, you will notice that your x values are negative, positive, 0, 1, bigger than 1, less than 1, okay? Which means there's no restriction on the domain. The range of these functions, which is the y, is the set of all real numbers from -1 to 1, which means the range of sine and cosine can never be less than 1 or bigger than 1. If you go around your unit circle, the biggest your points get for y and for x are 1. The smallest they get are -1 for y and x. So they'll never be less than -1 and they'll never be bigger than +1. The sine and cosine, okay, I'm tangential on here. The sine and cosine are periodic, which means it keeps going around in the circle. So where this coordinate point happens now, it will come around and happen again at a coterminal angle. It will come around and happen again at a coterminal angle. It'll come around and happen again at a coterminal angle, which means every single coterminal angle is going to have the same coordinate point. So if I know my values at 0, right, they are going to be the same at 2 pi. They are going to be the same at 4 pi. They are going to be the same at 6 pi. They're going to be the same at 8 pi. They are going to be the same at 232 pi, because those are even numbers, and even whole numbers are on the right-hand side of my unit circle. Odd numbers are on the left. So -pi, -3 pi, 17 pi, 213 pi, all of those are all going to be this coordinate point. So we will eventually be going around our circle multiple times, or you'll use the negative values to go the other direction. All right, so this one says evaluate the trig function using its period as its aid, which means they are coterminal. So you have two choices. One is literally subtract 2 pi until you get it into your unit circle. The other, and I would suggest this because subtracting 2 pi is going to get lengthy depending on how big they are, is take your value, convert it to a mixed number. So 13/6 is what in mixed number format? 2 1/6 pi. So where did we just say every even whole number lives? On the right. Every odd is over here. So no matter what this number is, if it's even, I'm going to go around my circle and end up here before I get to the 1/6 part, or the fractional part. Now this is a positive 1/6, and the 1/6 is the next angle at pi/6. My coordinate point there is √3/2 1/2. So the sine is the y. If that was -13 pi/6, this would be -2 1/6 pi. So I'd still go to 2, which is here. But instead of going counterclockwise because it's positive, I would go clockwise because it's negative. And that's 11 pi/6. And that coordinate point is √3/2 and -1/2. So we're going to get a lot more practice with these. But this is where you want to get to. I should be able to put like 23 pi/6 there. You should be able to figure out where that coordinate point is. Convert it and then find it. You're going to get given the unit circle to fill out, which means your answers are not going to come directly from your unit circle. You're going to have to apply the period. All right, so cosine of 5 pi, where's the odd whole numbers? On the left. What's the coordinate point there? -1, 0. Cosine would be -1. That's a negative. Questions on that one? All right, even and odd functions. So cosine and its reciprocal function secant are called even because their value will be the same whether you're finding it of a negative angle or a positive angle. And this means the cosine at pi over 6 is going to be the same as the cosine at negative pi over 6. The secant at pi over 6 would be the same as secant of negative pi over 6. And it's because the x is the same here as it is here. And the x is the same here as it is here. And then the x reciprocal is secant. So those both don't change. But all the other terms are called odd. And these change. So if I'm finding the sign of positive t, then the sign of negative t is going to be the opposite sign. So if I have sine of pi over 6, it's really hard to read. Sine of pi over 6, which is the y at pi over 6, which is 1/2. The sign at negative pi over 6 is going to be negative 1/2. So for all the trig functions except cosine and secant, if we change the sign, positive or negative, on the angle, we change the sign on the trig function. That's what even odd means. And that's because the y changes from here to here, the sign of it, and the y sign changes from here to here. All right, these, which we just talked about, are called the reciprocal identities, okay? You already know these. The reciprocal to sine is cosecant. The reciprocal of cosine is secant. Reciprocal of tangent is cotangent. Reciprocal of cosecant is sine. Secant to cosine and cotangent and tangent. So you could go in either direction. And this is how you'll see these used. It says use the value of the trig function to evaluate the indicated functions. So for A, this is even and odd mixed with reciprocal functions. If the cosine of t is negative 1/3, what's the cosine of negative t? Does the sign change with cosine? No, so it is also negative 1/3. What would the reciprocal be of the cosine of negative t? Negative 3. B says the sign of negative t is 3/5. What would be the sign of positive t? Negative 3/5. So remember, sign changes positive or negative sign. Only cosine and secant don't. And what's the cosecant of t? Negative 5/3. Flip what we just found. Questions on that one? All right, we end with the calculator. Remember how important your mode was? It's back. So the mode on your calculator can either be in radians or degrees. If this said find the sine of 35 degrees, my calculator has to be in degrees. If it says find the sine of 3 without the degree symbol, it has to be in radians, okay? So if you look at the 4 that are here, none of them have degree symbols on them. So you want your calculator to be in radians. Go to mode, third line, make sure it's selected radians. Every time you reset your calculator, like you did the second plus 712, it puts it into radians. So it should be there. So if I want to find the secant of 4.5, I'm finding 1 over the cosine of 4.5. I get negative 4.7439. What does it say? 4 decimal places. Yep. The cosecant of 0.9 is 1 over the sine of 0.9. And I get 1.2766. The tangent of pi over 2 is literally tan. Use the pi button. It's above your caret divided by 2. And we should know this already. Because what's the tangent at the top of your circle? Undefined, and your calculator will yell at you. because it can't find it. It'll say domain error. And then cotangent of negative 1.2 is 1 over tangent negative 1.2. And I get negative 0.3888. Questions? All right, that's 4-2. So I am going to open the assignment. I would say if you're a junior, use the weekend to do it. But I'm not going to make it due till Tuesday. So if you are not a junior, that's what you're going to work on in class on Monday with the sub, okay? So again, I'm going to open 4-2. If you're a junior, I would say get it ahead of time. Like do it like maybe before your PSAT. You will still have till Tuesday. But maybe your brain fried after your PSAT. But if you don't, again, it will be due Tuesday. Oh,